Oh, hi! I didn't see you there. My name's Eric. You might remember me from such films as Canoe Building or How to Automatically Export PDFs with Outline Fonts in InDesign. But today, we're building a tool in the shop. Why don't you come on, have a look. Okay, hi everyone. Enough goofing around. Let's get going. So some of you might already know that there is a healthy community of blind woodworkers. The industrial arts are taught at a few training facilities all across North America, including here in Toronto at the CNIB. Now, all the tools that are used in these workshops are the same. Same hammers, same chisels, same vice grips, the same drills, the same wire cutters, the same files, same Allen keys, same planes, the same vice grips, the same saws, the same screwdrivers, same files, same punches, same tape. But there is one exception to all this. Measuring tools. So here we have a humble speed square. Now, to some degree, speed square can be used for the same things, such as scribing lines. You can scribe a line, you can feel it tactily, you can cut along there, or if you want to line up your screws nicely, you can use it for that too. But these gradations along here are not relieved enough into the material that you can feel them and use them for actual measurements. Same problem occurs when we're talking about tape measures. So this is just your standard tape. Once again, these are not raised at all, although you can buy them with raised gradations. The problem is that they fill up with gunk. They're difficult to feel because there's barely a fingernail distance between each 1/16 of an inch. It's just not enough to really be certain about. There are talking tape measures. They run on batteries. When the batteries run out, you're toast, and it shuts down your project. Also, shops can be loud. So in a really loud shop, lots of noise going on, it's really difficult to hear the talking tape measures, and for whatever reason, they just don't seem to be preferred or end up getting used all that often. What is preferred is this. This is called a click rule. So I'll describe it. Click rule for you quickly. There is a rod, a tube. The tube is about 10 inches long, and inside the tube is a rod. The rod has threads, and the threads are 16 threads per inch, which means that if you run your fingernail along the threads, every inch you'll count 16 of them. The rod extends from the mouth of the tube, where there is a block of metal, which is about the size of a pack of gum, juicy fruit specifically, and that rod, fence has a little ball bearing in it, which presses into the threads and causes a clicking noise every time a thread passes them. That's why it's called the click rule, and the benefit of that clicking is it tells you every time you move a 1/16 of an inch. So I don't have a click rule with me, but I have something very, very similar which I've made, and we'll use it just as a click rule first, and then we'll show the benefits of this different design. So say I want to measure this block. So 4x4, I take my click rule, here's the tube, I grab the rod, I pull it out, and I line it up with the end. I put the fence on one end, and I put the end of the rod on the other end, and then I start to count these little rice-sized markings, which are exactly every inch along the device. until I get to the last one. And then I notice that when I get to the last one, there's still a little bit of distance between it and the fence. And to know that distance, I just count the threads. And I count 2 threads with my fingernail, which means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 inches, and 2 threads means 11 and 2/16 of an inch. So that's the length of this block. Great. Now, what happens if I need this hand free? I can't pull this out because this hand is busy doing something. So when might that happen? Well, that might happen if I need to measure a block of wood and I need to hold it against here to take a measurement and it's falling over, you know, either way, or it's just kind of a wobbly surface. Try to do it, not working. Another time that might happen is, what if you have an odd piece of metal? So I'm trying to hold this piece of metal, I'm trying to pull out this rod, and it's wobbling all over, and I'm just trying to stabilize it, and I can't till I finally get it. Then once you get it though, as you can see in the image of the click rule, there's this little knob here, and the locking knob is required to lock the measurement in place, and then you can come along and feel it. That's a huge disadvantage, because if anything happens and maybe you set the tool down hard, or you drop it, or you need to, you know, deal with some other things going around, you could easily lose your measurement if you haven't locked it in, and you could also lose your measurement even worse without realizing it. When that happens, you're stuck cutting pieces and you've got it wrong. Another reason that the click rule is not good is if you want to get a measurement. So say you don't want to measure the length of something, but you want to measure a certain distance into the workpiece. Then you need to pull it out. You need to count again, and then you need to check, and then you need to put it down on top of the piece, and now you can mark it. But again, it requires 2 hands, which, I mean, if you're trying to scribe that mark, you need that hand free. You don't want to be messing around with this, and it keeps you from moving quickly because you're having to think ahead and get all your tools together. That can be difficult in a busy shop where, you know, all your tools are already laid out. You're not sure where they are at all times. You have to find them. It's nice to have that hand free, which is why I thought it would be great if we designed a one-handed click rule, which is what you see here. The measuring rod can be operated with one hand. It clicks every 1/16 of an inch, which means you don't need to feel. You can just listen, and you can do anything you need to do with your other hand, like stapling the piece or holding your marking tool. In a future version, I would like to add a different click and a harder tactile click on the 1-inch marks, because at the moment, if you're counting every single 1/16 of an inch, that's a lot of counting on a larger piece. So in this instance, say I wanted to measure 3 inches into this 2x4, I would butt the fence of the tool up against the 2x4, and I would rotate the wheel with my thumb until I heard a long click. Then I would listen for 3 large clicks, and say I need 3 inches and 3/16. I would get 3 clicks, and then I would go 1, 3 little clicks, and now I'm at 3/16 of an inch. My other hand is already free. Scribe a line. I can feel that line here. Now I can take my speed square, butt it up against it. We're ready to go. If I was doing that with a traditional style click wheel, I would have to take it, pull the rod out, feel 1, 2, 3, then manually pull out 1, 2, 3 more 16ths of an inch. Then I would need to come over here and grab the locking nut, turn it down. Now I can come up and Scrabble line and take my measurement. The click rule that I have designed also has the benefit of automatically locking. So you can shake this, it's not gonna move. That measurement is locked in the second you dial it in. And that's basically it. That is the one-handed click rule. Thanks.
Your thoughts are important. If you want to leave a comment about the one-handed click rule, leave it on our YouTube video called One-Handed Click Rule on the Eric Forrest channel. If you're visiting us in person today, there is a QR code on a raised square sitting on the table in front of you. It will take you directly to our video. Thanks.